Hello, everyone, and welcome to today's informatech Automotive Group webinar, Winning Strategies in the Shift to the Software-Defined Vehicle, sponsored by GrapeUp. I'm Dave Zoya, Senior Director of Content for the informatech Automotive Group, and I'll be your moderator for today's event. Before we begin, let me explain how you can participate in today's presentation. To improve your viewing and listening experience, you can move your webcast windows around by dragging on the title bar, or resize them by clicking on their lower right corner. At the bottom of your screen, you'll find multiple application widgets. We welcome your questions about our topic, and we'll answer as many as we can following the presentation, but feel free to submit yours to the queue at any time. Just type it into the Q&A window on the side of your screen and hit the submit button. Please also be aware that today's session is being recorded and will be available for on-demand viewing. You'll be notified by email when the archive is available. Joining me today is Adam Kozłowski. Adam is a solution architect and head of automotive R&D at GrapeUp. He worked as a C, C++, and JavaScript developer before starting his journey to the cloud and machine learning world. Adam is an active advocate of Kubernetes and open source cloud native solutions. He's a huge fan of R&D initiatives, rapid prototyping, ML ops, and building great software products enhanced by ML algorithms. Throughout his career, Adam has worked with established enterprises such as Rick's Waterstadt, Porsche, and Allstate to help them build their mission-critical systems. Adam currently is responsible for consulting on projects specializing in cloud and ML ops solutions for the automotive industry. With that, we can get started. Adam, please go ahead and begin your presentation.
Okay. Hello, everyone. As introduced, my name is Adam Kozłowski. And what you have seen on the previous slide is more marketing version of the title. More down-to-earth version is how microservices and Agile can help you scale automotive software development. And I will try to guide you through both of the topics today, highlight most important aspects, and hopefully you can then later use that for building your own version of software-defined vehicle. As introduced, I represent GrapeUp Poland, and GrapeUp is a software development consultancy strategically focused on working with automotive industry. In particular, we cooperate with emerging technologies departments, connected car departments, shared mobility departments, sometimes even e-commerce departments. And we believe that we work mainly in the projects that are helping our partners, the automotive companies, to build their own version of the software-centric vehicles, and that the projects we're taking part of are the mission critical and very important for them. So by today, we delivered around 50 projects within the areas mentioned before, and we are privileged to work with customers from almost everywhere around the world. Just to mention, like Volkswagen, Porsche, or Rolls-Royce. On the map, you can see our development locations, also all around the world. On this slide, I'm not going through that in deep, but you can see some of the technological concepts that we were able to build successfully with or for our partners. And this way, we provided our piece of a puzzle to build a car that is connected, shared, autonomous, or electric, and electric, actually. Okay, coming back to the topic. Regardless what you may think about the concepts that I have presented on the previous slide, some people say they're just buzzwords. Others say that they are already established technologies. But I think we all together can agree on one thing, that the world of vehicle manufacturing has changed and is changing right now to more software-centric one. And the hottest buzzword for the next months or years will be software-defined vehicle. And we also in GrapeUp think that the software-defined vehicle will be the next great disruption in the automotive industry. But I just said that this is the next big disruption, so maybe let's start with what was the first or previous great disruption in the industry. So up to early 1900s, the car manufacturing was just a manual work. As you can see on the picture, it was time-consuming, labor-intensive, cost-inefficient. It was just hard work for everyone. And then Henry Ford, American visionary, decided to improve the process by introducing the moving assembly line. And what were the benefits of that change? It reduced the time to build a car from 12 hours to less than 2 hours, improved the cost effectiveness of such manufacturing, and as a result, allowed to make car a commodity in the long run. And given that outcomes, the automotive world considered this as the biggest disruption in the history of the industry, of the vehicle manufacturing. But if we fast forward to present now, and to actually understand the idea behind the second disruption in the industry, we have to agree on one more thing. And that is the meaning of the buzzword I mentioned before. What is the software-defined vehicle? And the goal of the software-defined vehicle change or revolution is to reduce the amount of hardware components and ECUs in favor of more general purpose, more multi-purpose CPUs. And in other words, making the car more dependent on the software and less on the hardware. This is also important in terms of availability of the chips which we are facing right now. And in my opinion, the moving assembly line was to Henry Ford and to whole industry what the agile delivery is to software development, industry or practices. If you still remember the times of the waterfall, that was the manual assembly line. So everything had to be done in correct order in the old automotive world. And if we look at the market studies regarding the Scrum, Scrum specifically, they say that Scrum, compared to waterfall, of course, is 6 times more successful while requiring only 25% of the investment and has 10 times faster payback. If we compare that to the previous disruption, the numbers are almost the same reduction in required time and the cost. But this is about the Scrum, and a lot of you who are working in the, either automotive industry or just in software development industry may say that Scrum is not very well for huge enterprises, not good enough for huge enterprises. And you are all right. That's true. The Scrum is good for small single projects. It's not easy to scale Scrum. But as there are different configurations of an assembly line, there are also different kinds of Agile. There is Scrum, there is Kanban, there is extreme programming, there is Lean. All of them are different, but none of them answer the important questions for big scale software development, like how to run 50 projects at once that are building, for example, software-defined vehicle, or how can we build a solution that components are built by 50 different teams. That's all the questions about the scaling Agile. And of course, as there are questions, there are also some answers. And we can see that, for example, there is a Scrumban, which is an answer for one of the answers for scaling Agile. And Scrumban is based on a Kanban concept. It's some people say this is the most agile way of being agile. There is no estimation, and there is no overall deadline of building projects. This is very often used for infrastructure, like tasks, where it's hard to predict or estimate the end of the work. But what it means, it also means when it's hard to estimate, it's not good enough for enterprises. The other example of scaled agile is less, and less is a process that is based on simplicity when working on multiple projects at once. So the only addition to regular Scrum added by less is hierarchy of product owners. What it means is that the team may not be fully aware about the overall business goal and the way, the transparency within the project, because only the people responsible for planning, for building the business use case, like product owners, are part of the design and planning sessions. It's just not enough for enterprises, but it's very quick if we want to build something smaller. But there is one more, and it's called SAFe, or Scaled Agile. And SAFe is a set of organizational and workflow patterns for implementing Agile in a big enterprise scale. It provides structured guidance, like in a rule book, on roles and responsibilities, how to plan the work, how to manage the work, and the values to uphold. For example, values like alignment, built-in quality, transparency, or leadership. And if we look on the diagram, what SAFe adds over the regular Scrum that we can see on the bottom is 2 additional big layers of the management. The tactical layer, which is responsible for the solution level design, and the strategical level for the, let's say, senior management to maintain the vision about the whole portfolio of the system. Okay, this is more structured guidance. There is a lot of documentation required, a lot of work to be done to build this kind of working software development system. But it also works very well for the enterprises because it's built the same way as the enterprises are built, in a similar hierarchy. But adoption of SAFe may not be easy. So I have asked our teams what is the most important aspects of that. But let's start with the aspect that, in my opinion, is most important for the automotive industry. That is coordinating software development with vehicle release schedule. And we all know that even if we go fully agile, the being agile does not apply to actually building and releasing a vehicle to the market. There is always a deadline that cannot be moved when the vehicle is actually starting to being sold. And even if we use the modern agile development lifecycle, we need to make sure that end of the day, we have a working piece of the software to put in that specific vehicle. So it has to be agile, but it also requires a lot of coordination regarding the timelines, deadlines, and the amount of work to be done before the vehicle is released. And SDV, a software-defined vehicle, actually adds more flexibility to that process, because before the software-defined vehicle, all features that had to be built in the vehicle should be ready for the vehicle release, especially the critical ones that are required to operate the vehicle. And any kind of update required to visit in the service center. After software-defined vehicle, of course, within the full implementation with over-the-air updates, the features can be developed and added after the vehicle is released. So only the bare bone, only the basic software that is required to operate the vehicle can be designed and developed in the initial phase. And all additional features that are not that required, maybe optional, maybe can be added later, can be released later on after the vehicle is manufactured, or at the same time when it is manufactured or stored in a lot. And as I've mentioned, I've asked our teams what, in their opinion, are the most important hints for implementing SAFe in your project. And I asked for 3, they came up with 4. So let's go through the ones that they have mentioned. One which is a little bit surprising is that they said to use the modern planning tools. And the surprising part is that not everyone used that from the start. If you use Jira, there is Jira Structure, Jira Portfolio tools, and they help a lot with managing SAFe projects. So if you want to start with SAFe, make sure to use the planning tools that are required for SAFe, that are working with SAFe well from the start. It will ease your transition by a huge amount. The other one is to take care on proper definition of business goals on all levels. So, of course, on the portfolio level, the business goal is more generic than on the operational level. But on each level, the definition should be clear for everyone in the project. And the decomposition going down the levels to the development teams has to be done in a way that everyone understands what they are building and why. And that leads us to the third one, to focus on transparency and traceability. And this is very important if we are building a big solution. And we have trained and experienced development teams because we can rely on them to understand what they are doing and to let us know if we are going in a wrong way. If you are building something that is not going to match the existing solution, the existing architecture, or not work very well within the current system. But to do that, we need to make sure that they are able to see transparently what they are building. So just giving them the development task, the user story, with only a piece of the code that they have to be done, without the ability to trace how it fits the solution, how it fits the portfolio, may lead to the result that they built something which is working correctly, but just doesn't fit the whole system. And they couldn't say that out loud when working on it, because they had not enough traceability and transparency of what they are actually doing. And the last one they mentioned is to make sure that the paperwork and documentation is lightweight as possible. And that's really important because the SAFe itself adds a lot of requirements regarding the documentation, the paperwork to be done. And if we add a lot more on top of that, they are just burdened with making documentation and have not enough time to actually build the software. Okay, so that's about the SAFe. So let's talk more about the technology. And if we think about the cloud software development in general, the idea of the cloud itself, the cloud infrastructure, in the sense we think about it today, is fairly new. Probably most of you remember the early days of the AWS. It was, I think, around 16 years ago when it was launched. But as in the same way as for the vehicle manufacturing, it didn't start immediately from the rolling assembly line. The first cloud was just a virtual machines. And the way it was used, people just lifted and shifted their existing projects to VMs in the cloud. But even though the virtual machines was quite a leap from bare-bones servers hosted by themselves or in data centers for most enterprises. But the big disruption for the cloud software development was containerization or introduction of Docker. Because in the parallel to the new technology that is being introduced with using containerization or using Docker, there has to be another change. It was changed of the architecture. And the architecture that were chosen by most of the architects, developers, and enterprises was microservices. And why is that? Or maybe let's start, what is the microservice architecture? And microservice architecture is a service-oriented architecture. It means that each part of the system is responsible for a single business capability. It's fine-grained, so there are a lot of microservices with different responsibilities, owned by small teams, and can be deployed independently. Apart from the microservices, all connected external services like config servers, databases, or storage is also interconnectable and loosely coupled, so everything in the system can be easier or less easy exchanged with a different type of the system. It is a little bit plug and play, like the parts of the vehicle, which makes it easier to maintain. Okay, so let's go through the advantages of using the microservices, and I have split them into two main groups. One is the faster development of the software, and the faster development is because it's easier to maintain dependencies and integrations because the architecture in a way exposes them as a facades, so they can be easily swapped. There is a common API that has to be used, and when the interface is preserved, it's just easy to switch the integrations and manage them. Because the services are organized based on the business capabilities, it's easier to build smaller teams to maintain the specific domain. And the team that is responsible for that specific microservice and that specific domain can get experience in that specific business idea, and this makes them better in doing their work. The other part is pluggable in architecture. So if we have a lot of small parts and the ability to add new ones easily, it makes it easy to add new microservices to the existing system without breaking anything. In the same way, we can add another external services without breaking anything, because in most cases, it doesn't require to change everything. Just one or two microservices has to be changed, or even none. And the last important part for this faster development is that the microservices are technologically agnostic. So it is even possible to have different technology for each microservice in the system. Of course, this is not a wise idea. It's just a possibility. But if there is a business use case that requires a specific framework that is only available in one technology, we can use just that one instead of forcing everyone to use one framework or one programming language, because everything is a monolith and has to be built on the same framework. The other group is security and reliability. And the microservices architecture gives us security and reliability in a way that it improves fault isolation and security. Because if we have multiple microservices with very specific purposes, if any of them breaks, we don't have a collapse of the whole system. Not everything in the system breaks. This is just a single part that breaks. So if we imagine a system that has for example, invoicing system that has something wrong in it, but this is the whole e-commerce system. If we have a problem that the invoice system is not available, the whole system is still operational. So we can log in, we can see all orders, we can add new order. The only single part is has a problem inside, is broken. So this is the only part that has to be fixed. In the same way, if someone finds a security breach in one of the components, other ones may not be prone to that security breach. What adds to the reliability is the component granularity, because if we have everything split into small microservices, we can add more of them to improve the concurrency. So we can split the work on multiple microservices, and this makes them more reliable. If any of them breaks for some reason, doesn't matter which one, the others can do their job and answer the requests. And in a similar way, it gives the better scalability and scaling costs, because if we can easily add more instances of microservices and in the same way reduce the amount of services if they are not required, the system is more scalable, and it's cheaper to scale it because we don't have to scale everything at once. We can scale only the part that requires scaling at this point. And if the whole architecture is built correctly, using infrastructure as a code system and a good way to connect microservices with the external systems and with themselves, for example, using the config servers and service registries, we can achieve the environments parity easily. So we can have the same production environment as the development environment and integration environment with just 1 or 2 clicks of the mouse, which improves the reliability greatly. Okay, but you may say that in theory what I said sounds great, but how about practice, how it works in practice? So the first modern implementation of connected car architecture for Porsche was built using that safe methodology and microservices, and it was done in cooperation between GreyPub engineers, Porsche engineers, but also Audi engineers. If you would like to know more about this project, you can search on YouTube for Cloud Foundry Summit 2019. There is a whole presentation about that. But what I just wanted to say here is that it was a very successful project. Most of the Porsche projects being built later on is based also on safe microservices. And from what I know, most of the OEMs right now are either using the safe and microservices, or they are introducing them very soon. And thank you. That's it from me.
Well, thank you, Adam. That was a great presentation. I think for me, it kind of hammers home the amount of cultural change and just the huge complexity involved in this transition to the software-defined vehicle. I mean, this is a huge task, isn't it?
Yeah, that's true. There's a lot of work to be done to have the full transition.
So we have some questions coming in. If you're ready, I just want to remind the audience that you can still put some questions in the question box on the side of your screen. Just type it in there and hit the submit. But if you're ready, Adam, we'll get going.
Okay.
Are there any disadvantages of safe methodology that you want to point out here?
There are some, but I think the 2 most important ones to mention here would be the additional administration and paperwork that is required to build this system, because there is a lot of new roles to be added, a lot of communication and business processes and environment changes to required to build this the safe, scaled agile software development lifecycle. So it's not that easy to change that, and some may even say that it's in opposition to the agile if we have a lot of administrative and business tasks added for and required by the developers. And the same thing for actually using the safe, adding all the required components in Jira, all the stuff, transparency, traceability is required, and it has to be done. But it makes the agile less agile because you have to plan everything up front and build that into your ticket management system.
Okay, we have another question about SAFe. Have you ever been part of a project where using SAFe methodology was impossible?
Yes, but this is the question that may be answered in multiple ways. So for a single project, SAFe is probably too big, and a lot of projects that are highly focused on infrastructure are better with the Kanban and the Scrumban I mentioned on my presentation too. So introduction of SAFe when there is no way to estimate the amount of work and there are problems with communication between departments may be too hard and maybe even not possible. But in general, it's also not wise to introduce SAFe if you are a very small company, because it adds a lot of administrative burden with no immediate advantage. So it's good, but if you are a big company working on a big solution.
So you really have to have an understanding of where you're at before you try to implement this. Are microservices only dedicated to be used in cloud projects, or is it possible to use them also when you are building software for the vehicles?
Well, that's a great question, actually, because microservices is not a piece of software or not a framework or a solution. It's just the technological concept. So it's not, you don't have to use cloud. You don't have to have cloud to use microservices. And of course, the software development for the vehicles is mostly on the embedded side. And some of the architectures of the embedded side are not working very well with the microservices. But if we think about the systems like Android Automotive OS, each application can be also treated as a microservice, or each service running in the background can be treated as a microservice. So in this way, yes, the systems in the vehicles can be developed using the microservice architecture. Plus, some of the OEMs are either using right now or experimenting with using Docker inside the vehicles, in the infotainment, but sometimes even in the ECUs. And then microservices are also a great choice.
Okay, we have one of our audience members says, I'm new to Agile Scrum. We are a smaller team and use Aspis and use a system for keeping the schedule changes records. So far, this helps us to get to quick schedules. How will your product help us?
So we don't have a product, so that's one thing. We are software development consultancy, so we help you build the teams and help you develop the software, or help you implement Agile into your organization, but we don't have a specific product to be used. And if you are a small team, I wouldn't recommend using this SAFe, actually, because there is a lot of work to introduce SAFe in a small team and not a lot of advantages to that. But I think your decision with using SPICE or automotive SPICE is a good decision, because this is the process that was used also by the OEMs before the SAFe. So that's a good choice. Good for you.
Okay. Where are the opportunities for suppliers to play significant roles in software? There seems to be a little bit of a discussion of how much the OEMs want to control. Where do you see the opportunities for suppliers to get involved?
That's a very common question, because it seems for most of the OEMs, the software-defined vehicle revolution is a lot bigger than they expected, and the amount of software that has to be developed because of that is much bigger than actually probably everyone in the world expected, which means that they have to either hire or get somehow more software developers. And while they are not really, that's not their market, that's not what they did previously a lot, it might be hard for them to build huge teams shortly. And that's why they might need suppliers to help them build the teams, especially suppliers like GrapeUp, who have people, developers, project owners, project managers, who has experience with building the automotive software, and they can help not just by developing a very specific feature, but also they can help with understanding the business needs and what is required and how the feature will benefit the solution or the vehicle or the system that is being built. So that's a big opportunity for the suppliers, because the role of the software is huge right now. The amount of software to be developed is tremendous. So OEMs need to somehow think how they can introduce suppliers to help them with that. And we have a lot of questions about helping, like developing either the whole solutions or just parts of the system, just because of that reason, because there is a lot of work and not enough people.
Okay, if you are a small team and SAFe is not the right fit, then what is? What would you suggest?
I think I would just suggest using Scrum if you can estimate your work. That's probably the best for the smaller teams. But sometimes if you cannot estimate your work, because what you do is really hard to estimate, is more like research work or just things that you are not sure about how long it will take. You can start with the Kanban. Kanban is probably the easiest type of Agile to start with. And then when you feel more comfortable with working in the Agile environment, then you can use the Scrum. There's also extreme programming, which is great if you are trying to upskill the team members, because it requires pair programming. So people with less skills in that specific language or that specific framework that is used can get upskilled very quickly with the pair programming and working on the same tasks together with more skilled colleagues. So if this is if you're in the situation when you want to expand your team quickly and you have already experienced developers, or you have an ability to gather them from supplier, then extreme programming is very nice to build a very skilled team too. Okay,
we still have time for questions, so do submit it in the Q&A box if you have one. Is AutoSAR methodology helping with what you are saying?
Yes, in a way, but the AutoSAR has like different responsibility. So it's not that responsible for managing the project itself. It's more responsible for making sure the architecture of the whole system. Actually, for AutoSAR, I think it's mainly the embedded system is done in a correct way in a way that it's secure and reliable for the automotive industry. But of course, if you need to develop this kind of software, using AutoSAR is helpful with safe or without safe.
Okay. How do you see the shift occurring to centralized processing? Where do you see think the lines will be drawn between edge and centralized processing in future SDVs? Did you get that question?
Oh, sorry, I'm on mute. I think, okay, so I repeat then. This is a great question, and I think we are, in a way, right now in a very dynamic environment, because we are at the point where I think all, or let's say most of the vehicles produced these days are connected to the internet. So there is an ability to offload the processing to the edge or to the cloud. But of course, the connection is not reliable enough and not fast enough to offload mission critical systems or, for example, ADIS systems or autonomous driving systems, because we need very low latency to move this kind of computation even to the edge systems that are nearby the vehicle. But also we observe that the whole industry tries to solve that problem, especially with the low latency, and the answer seems to be 5G these days. But the 5G actual infrastructure is not widespread enough to be used to move more computation to the cloud. And it doesn't look like it can be improved very quickly. And it doesn't look like the coverage of 5G will cover the whole world at all. So I think that this line is now drawn like most of the mission critical, or maybe not the other way. All of the mission critical parts has to be on ECU. All driver assistance has to be on ECU. Anything that doesn't require immediate response can be in the cloud or can be at the edge. If we get reliable 5G in the cities, we can try to offload some of the driver assistance to the edge. And at this point, we can also think about vehicle to everything, vehicle to X communication to improve the driver assistance systems, because the latency will be probably low enough to have the actual advantage of connecting to the vehicle nearby and communicating with it in a time that it's not, it's still nearby when we get the response.
Is there an agility advantage to being on the cloud versus being on board the vehicle at all?
That's a very good question, but the answer is like the most known answer for the consultants, that it depends. And it depends mainly on how you design the onboard software. Because if the onboard software is designed in a way that microservices can be used on board, in parity to microservices being used in the cloud, then the Agile helps a lot. But from what I know, even developing the embedded software for the vehicles can benefit from using Agile. It's not the times when we develop any kind of software in waterfall these days. So for the embedded systems, the Agile is great. But even like for some of the OEMs, adding microservices to the onboard can be beneficial.
Okay, well, getting close to the end, so let's make this the last one. You talked about agility obviously being the key in development of software. what's realistic in terms of a timeline for updating and introducing new software in an SDV? I mean, the auto industry has struggled with quick turnarounds on things like this. You know, what do you think is realistic down the road?
It's really hard to say. I think that some of the OEMs are aiming to have the new update like in 24 hours from being developed. And I think that's fair. We obviously can make that shorter, but there is always a risk of not testing something enough or breaking something important. But I think that the realistic timeline from the end of the development to introduction of the feature in the vehicle will be probably like 24 hours if the testing system is done.
Well, that's pretty quick, right? I mean, it's a pretty ambitious goal, it seems.
Yeah, but if we look at what Tesla does, if they are able to do that, probably everyone is.
I'll sneak one more in before we end here. Will introduction of microservices not introduce latency issues in SDVs?
It really depends if this is a question about the cloud or the vehicle. Because if the question is about the embedded system that it's done in a traditional way versus the microservices, there can be additional latency, but only if the communication protocol is not designed in a real-time way. In cloud, it doesn't really matter.
Okay, well, with that, I think we'll end it there. I'd like to thank our presenter again, Adam Kozłowski, for an outstanding discussion. Adam, thanks so very much for being here.
Thank you so much. It is a pleasure.
I'd also like to thank GrapeUp for making today's event possible. As a reminder, you will receive a follow-up email that will include a link to view a recording of today's presentation. So if you found this event useful, please share it with your colleagues. Once you leave the event, a short survey will pop up in your browser window. We'd appreciate it if you would share your feedback on this event, as it helps us to provide you with content most interesting for you. On behalf of the informatech Automotive Group, I want to thank all of you for joining us today. Have a great rest of the day and week.